Hello everyone, welcome to the SNIA Ethernet Storage Forum, or ESF, presentation on Rockin and Rollin with SMB3. I'm pleased to have with us today Ned Pyle, SMB Program Manager at Microsoft, who will be our primary presenter, and we're going to talk about what's new with SMB3, what's better, what's different, and how to make sure you're getting the most out of this exciting file-based network protocol, or network-based file protocol, I should say. As I mentioned, today's presenter is Ned Pyle, shown here with some of his lovely dogs. They will not be helping with the presentation, but they will be lending moral support. I am John Kim, Chair of the SNIA Ethernet Storage Forum, and I will be your moderator today. Before we get started, some brief words about SNIA. So just in case you didn't know, SNIA is a very active organization that works on storage networking. It's the Storage Networking Industry Association. There are over 160 unique member companies and over 3,000 active contributing members and over 50,000 total individual members within SNIA. You can learn more about SNIA at snia.org/technical and more about SNIA ESF if you go to the ESF page. A quick legal word. The material contained in this presentation is copyrighted by SNIA unless otherwise noted. Any member company of SNIA can reuse this material subject to the conditions listed here. The presentation is a project of SNIA. Neither the presenter nor myself are attorneys, and nothing in this presentation should be considered legal advice. Any information within here is used at your own risk. That said, let's go ahead and get started. So I'd like to introduce Ned Pyle, our very special guest today, and he's going to start out with a timeline and history about the evolution of SMB. Ned, are you ready to go?
Thanks, John. Good morning, everybody. As mentioned, I'm Ned Pyle. I'm a PM at Microsoft. And today I'm going to talk about SMB. I'm mostly going to talk about SMB 3.1.1. I'm going to, I know you see this history slide right now, and you're thinking like, oh no, they're going to give me a long, boring history of SMB. But I'm really not. This is going to take a minute or so to set the stage and sort of show us a little bit of the hierarchy of SMB itself, because you're probably running all versions of SMB right now, whether you know it or not. But I'll be drilling into SMB3, talking about a lot of its capabilities. Have sort of a quasi-demo. You really can't demo on this platform, but I'll be able to show you some real-world examples of SMB3 being used pretty effectively. And I've got plenty of spots in here for questions. There'll be some question breaks, so if you keep just feeding those questions to John, he'll organize them for me, and every so often we'll stop and take some of them. If you don't get your question asked, or you just want to follow up with me offline after this, you can always email me. It's just Ned Pyle, NEDPYLE @Microsoft.com. Or you can, the easiest way and the fastest way is just catch me on Twitter. It's @NerdPyle, because believe it or not, there was already a Ned Pyle out there when I came to Twitter, even though I thought I was the only guy on Earth. Okay, so SMB, let's talk about a quick timeline. The 1980s was this sort of pre-SMB period where you had some pretty hilarious sort of protocols of this that came out of IBM and some other companies, and then eventually reached the 90s where SMB1, as it later came to be called, and CIFS, a word that I despise, that was invented by Microsoft and then gotten rid of. Then everybody else kept using it after we had gotten rid of it. Then along came around the Vista time frame. In Vista, SMB2. I'm sure nobody noticed it because it was in Vista, but by Windows 7 you probably were getting comfortable with it. Then came, over the last few years, starting in 2012, and with that OS, Windows 8 in 2012, SMB3. And SMB3 was a real major departure. I mean, SMB1 was a user protocol, and SMB2 was still kind of a user protocol, and 3 was really more of a data center protocol. And that brings us to today, which is SMB 3.1.1, which came out in Windows 10 and Server 2016. Now, SMB1 still exists heavily. I'm going to come back to it a little bit later. Even though this is a presentation about 3, I have a big bone to pick with SMB1 and with you. But it's found on a lot of really decrepit stuff. Windows Workgroups, Landman, the places where it existed, and all the way up to XP. And 2003, it was the only protocol we had for this. It is still massively used, especially in NAS appliances, things of that nature, because it's so ubiquitous. It's been around forever. Everybody supports it. If it's Linux or Windows or Apple, or honestly, anybody can get SMB1 working, which is a real shame because it is complete garbage. And it's really, really unsafe. It's spectacularly slow and chatty, and I hate it like poison gas. So we're going to come back to SMB1 in a bit here. What I really want to start talking about is some of the more modern pieces. So SMB2 brought along sort of the inkling of what we were going to start doing in SMB3. It was more user optimized, and we started doing some more interesting things like compound requests, doing like large MTU, supporting a more efficient sort of transfers of data. We started doing these caching operations that would prevent you from having to browse every single time you went into, say, Windows Explorer or whatever your file manager of choice was. We'd be able to cache a lot of the information locally and not have to keep rebroadcasting it over the network, which is really good if you were in branch offices. And SMB2 was really kind of a branch office optimized protocol. It had a nifty concept called durable handles, which meant that you could, reconnect to a temporarily disconnected file without having to, restart the entire operation. We hold on to some of that information. And we started getting a little bit more up to date on things like, the signing cipher suite stuff. And before this, and in SMB1, it's MD5. I mean, it's like pocket calculator breaking stuff. Now, so we get to SMB3, and where the fun really starts is starting in 2012 in Windows 8. This is really a protocol that we were no longer thinking of as something that you or I would use to go copy a file, from our desktop to some share. It was being designed and optimized now for data center use. Really think of it as a fabric protocol now. And we started building these features that I'll go into a little bit later, like scale-out file server. And we started building these actual real, production application systems, like Storage Spaces Direct and Storage Replica and other features that would rely on SMB3 as the transport, as the protocol. So it was finally starting to live up to its original name. I mean, SMB stands for, if anybody remembers here, Server Message Block. But it was never a block protocol. In its history, it was always a file protocol. And then finally, after 25 years of evolution, it really is sort of evolving into this sort of pseudo-block protocol, the way that we use it here inside Microsoft and the way that some of vendors and manufacturers are starting to use it now. We did make some significant changes to it for the end user, but it's a much more modern end user. In the past, the end user scenario was thinking about, how can we be efficient on the wire? WAN networks and user connections are really, really poor. That's what SMB2 was trying to fix. SMB3 says, holy crap, why is everything so unsafe? Why is the whole world insecure? Why is everybody constantly breached and owned? And so really the major factors we took on for SMB3 in the user perspective is around security. And a lot of my talk today will be about security. All right. And I want to hit this one more time. Please stop saying CIFs. Please don't say CIFs anymore. I hate the word CIFs. If you ever met S.W. Worth, who's a SNIA member for life as far as I know, he would love to always point out that CIFs, which was invented by Microsoft and was called a common internet file system, was not common, didn't go over the internet, and wasn't a file system. And that's why we went to calling it SMB. So please stop saying the bad C word here. Okay, SMB3. We have really three pillars to talk about today. I'm going to break out. This whole presentation is really arranged around these three pillars, then followed up with some sort of quasi-demoing. The first one is security. The next one is scale. The next one is performance. And these three areas we're going to talk about, let this little guy catch up and run, encryption, pre-authentication integrity, guest blocking, which I'm suspecting that almost no one here will know what I'm talking about on guest blocking. And I hope you learn this one out of it. If you get nothing else out of this, I hope you learn that one. Transparent failover, scale-out file server, the RDMA, or what we, inside the protocol, we call it SMB Direct, which is kind of a brand name. It's just remote direct memory access usage of the SMB protocol. Multi-channel operations. And so we're going to start with security. So the biggest fundamental shift in SMB 3.1.1 as a protocol is around security. SMB 3 and 3.02 brought along the major features that I'll be talking about, the ones I just showed. But the really radical work we did in security, the stuff that finally, in my opinion, made SMB a properly secure protocol, didn't really happen until 3.1.1. And I'm not just saying that because that's when I, started being the PM of SMB. It's just because it's true. Okay, so SMB supports encryption and signing. You've known about signing since day one. You're actually doing signing right now, whether or not you know it. If you have an Active Directory domain, every time your computer boots up and does group policy refresh, or every time you refresh your group policy, domain controllers require by default that it be signed. That's the only guaranteed signing inside of Windows. And I got a little bit more detail on that in a second to talk about. But that's always been there, and it'll always be there. Encryption came in SMB3, and that's where we finally added real, proper end-to-end encryption. And I'm not going to insult anybody's intelligence here, but just real quick, the difference between signing and encryption is the signing is the integrity of the communication. We're just making sure, that nobody tampered with it. We're not protecting it. Somebody can still read it, but they can't change it or alter it. And then encryption is, privacy. It's not just the tampering protection, but it's also not allowing anybody to see the data. Okay. Now, in 2012 and Windows 8, really, so SMB 3.0, we came up with the first encryption, and it used AES 128 CCM. And as anybody here who works on crypto knows, and which we should have also known at the time, but we're being boneheads, CCM is pretty slow. And there's another iteration of this called GCM, which is considerably faster. They have the same exact protection level, but they actually just operate more quickly and more efficiently. So in 2012 R2, so basically in SMB 3.1.1, we started supporting the faster GCM protocol. And that actually gave us some pretty good results. Both of these things really sort of require that you use a set of hardware called AES-NI that comes from Intel, and it accelerates these types of AES operations. We also updated signing, which, like I said before, is integrity, and gave it the AES CMAC, which is safer than what we did in SMB2, but it is the sort of slowness just like CCM. And we prototyped and have not yet released, and don't really have a timeline, doing a GMAC implementation for signing, because we are in a paradoxical situation right now, believe it or not, where you will get better performance encrypting SMB than you will signing SMB, even though encryption is safer. Your bang for your buck right now is actually to encrypt, not to sign. Like I said, this I put an asterisk on requires. It doesn't require it physically. You can run your encryption and you can do SMB without using these enabled chips, which came around since Nehalem, Intel Nehalem's generation 2. So you'd have to have a pretty old machine right now not to have these things on the motherboard. If you don't, it'll all just happen in the normal CPU instructions, and you will see a significant hit there. You will basically spend most of your time encrypting and decrypting not doing other work. Now, our encryption is actually per share or per server. You can take it all the way down to, I want to encrypt this share and not that share, which is a little stupid if you think about it. We're being flexible, but in sort of a stupid way because, if you care about encryption, you should just care about encryption, not, everything on this server should be important, not some of it. If you've already noticed, I've already insulted myself and Microsoft at least 10 times now, and we'll see if I can get to 100. That's just how I roll. So, UNC Hardening, everybody raise your hand if you've heard of UNC Hardening, and I'll just observe you through your webcam and count. Looks like about 50 people. UNC Hardening is a feature of security which we introduced in Windows 10, and we actually created a backport of this that goes all the way back, even within SMB2, all the way back to Vista. It does not protect XP or 2003. It is man-in-the-middle protection. What is man-in-the-middle protection? You're just trying to prevent somebody from tampering with or intercepting and redirecting you off in some other way in the middle of you connecting to an SMB server. It has an interesting model. You have to pick one or more sort of protection levels, and you get to choose. You can choose mutual auth, which typically in Microsoft world means Kerberos, signing, or encryption. So you can pick two of these, because signing and encryption are sort of exclusive of each other, and then you would probably always pick mutual auth. And what you're saying is, I would like this particular connection to guarantee to me from the client side that it's going to have mutual auth and it's going to be signed or encrypted. And what that means is the difference here is if you looked at all the history of SMB and all of the settings and all the dialects and how it all negotiates, the server has always made these decisions about, what it supports and what you're going to do and, who's going to do what, which is a really stupid idea because if I'm going to ask the server how secure we're going to be and the server is an evil garbage machine that's trying to be bad to me, he's going to tell me, oh, you don't need any of this stuff. You should just talk to me in the most cheerful, unsafe way possible. So what UNC Hardening really says for the first time is, I have a client, I'm going to set some minimum rules here about what we're going to do. And we're actually building on top of this even now as I speak, where we're going to start adding the ability to, in Windows, even say, these are the minimum dialects that I will support for, not dialects, but protocols I will support for SMB itself. So I could say, even though I might support running SMB2 on my machine, I will only allow my client to talk to people over SMB 3.1.1. So there's a little nugget of something that nobody knows about that you got by attending the fine SNIA organization's presentation. You got to have a little sneak peek. Where's my mouse? Okay. What all you're doing with this is you're specifying UNC paths, and you can use wildcards. You can by share, by server name, by some wacky confluence and overlap of those. And by default, we actually do this. It's been happening this whole time, where you deployed Windows 10 machines. They've been doing this without your knowledge, unless you went and changed it. They will automatically guarantee and require that sysvol and the net logon share and domain controllers are signed. So when you're connecting to them, those connections are signed to those servers with any share of that name, and that mutual auth is enabled. It's not, you can turn it off, but right now it's just happening by default on any Windows 10 box you have, or 2016.
Yeah, this is John. Let me interrupt with a couple of questions just to clarify a few things. So
Sure.
You said that, so I understand from what you said that when I do decide signing or encryption, that's decided on a per server or per share level. But when I do decide if I'm going to do UNC hardening, that's done specifically per UNC path.
Yes. That's,
and are these two,
go ahead.
Are these decisions mutually completely independent, so I can make the decision whether I want to do signing or encryption completely separately from whether or not I do UNC path hardening?
Yeah, they are independent, but UNC Hardening always wins the rules. So the only way you could stop UNC Hardening from getting what it wants is by telling the server specifically that it will not do signing, or it refuses to do encryption, in which case the client simply will not connect anymore.
Got it.
And you get some wacky error.
Okay, and when you talked about, you know, the differences or the pros and cons of encryption versus signing, is that an either-or choice? Do people say, I'm going to sign or encrypt, or can they do both?
You should always choose. Once you do encryption, the signing is sort of is overlapped in functionality. It is possible under certain circumstances, certainly in non-Windows implementations, to do both. We only let you do one at a time. So if you pick encryption, you're just going to do encryption and signing. If you could do, and this goes for any protocol, if you can do both, there's really not much of a point to doing signing when you're doing encryption, because you're getting signing effectively for free inside of it.
Got it. Okay, makes sense. I would like to remind the audience, as Ned mentioned earlier, if you have any questions, please do submit them through the question panel. We have a few that have come in already, and we will pause for questions once or twice in the presentation, plus take any remaining questions at the end. So please do bring your questions online as we're presenting. Ned, please go on.
Sure, great. So I'm going to sort of demonstrate what this all means right here, because it's a little hard to understand when you hear about, you know, the UNC hardening. You might hear it called MUP hardening too sometimes. So I built a little example. So this is the Nedbucks, no confusion with any other company that looks precisely like this logo, coffee shop. And I've brought my laptop here, which of course is a fine Surface from Microsoft, and I boot my machine up. My machine is domain joined, so it's going to try, even without me being anywhere near a domain controller, to go and do domain controller thing. It's just going to try and go find my logon script, or in this case, a computer startup script, for example. And ordinarily, I'd be at the coffee shop, and this would, would fail. Nothing would happen. In its efforts to try and go through, the Wi-Fi router inside of the Nedbucks, and it would be trying to go to this spot here, some domain controller that is in the office that I really can't get to, right, which ordinarily hosts that script. No big deal. It would have failed. We would have moved on. I would have logged in with cache credentials, and I would have started working on my Great American Novel in the Starbucks. What happened what we started seeing an actual attack, this is not a theoretical attack, from some very clever, probably nation-state actors, was they would go into that Starbucks, they would compromise the router, which was trivial to do because almost all Wi-Fi routers are garbage, junk, easily compromised. Then they poisoned the ARP tables inside that router, meaning that whenever I would try to go find some domain controllers, it actually would work, and I would end up going to a server in the Starbucks running on somebody else's laptop, named after one of my DCs, because some scouting had been done, which actually did serve up this script PS1 file. And because my machine wasn't requiring all of these levels of signing, all these levels of mutual auth, all of these pieces, it would gladly run this file. The server would have like guest auth turned on so that my password didn't have to work. It would just fly right in. And it would start running whatever that script was, which probably installed lots and lots of control software, and now my poor Surface book there, Surface is owned, and from that point on, the attacker can just take over my entire life. That's a real thing. With MUP hardening in this scenario, UNC hardening, this couldn't happen, because the conversation I would have, the mutual auth conversation, couldn't succeed with a guest logon. It had to go through an actual credential being used, and that needed to form, a signed or encrypted communication with mutual auth. And the only way for the attacker to do that is to actually really have one of my domain controllers, which is a different problem, right? If they've walked off of the DC and they're standing around on the Nedbucks with my DC, sort of all bets are off. They've completely infiltrated the entire company and taken over. And honestly, I don't know why they're bothering at that point, because they're inside the company. Quit messing around with Starbucks. Okay, so that's what UNC hardening is designed to prevent, and does prevent. Then we built this thing called Pre-authentication Integrity. This is very new to SMB 3.1.1, and it is an additional man-in-the-middle protection for the attack where you are trying to stop somebody from downgrading capabilities. Okay, so what are capabilities? When you go through session setup inside of SMB, if you're familiar, you're going through and you're connecting to a session set. You're basically pre-authentication, authentication, session setup, tree connect, and going through and getting all of your, capabilities like I support signing, I support encryption, I support doing multi-channel, all of these sort of capabilities inside the dialect. What this is doing is now signing the entire setup phase, which was unprotected in the past. So the session setup is signed, the tree connect is encrypted and or signed, depending on which, what the thing will support. And then it's impossible to downgrade the capabilities now, so you don't have the ability to stop the client from showing up asking in a very weak way what it wants to do so that somebody could eavesdrop on it or do other nefarious bad things. This replaces something we have called Secure Negotiate, which has been around for quite some time, since SMB2, but which failed to protect these phases of the connection process. And you can't disable this. So you can't disable pre-authentication integrity, and it's starting in Windows 10. And this is a Windows-specific implementation. It could be different if somebody was running a licensed or third-party version of SMB. You can't disable Secure Negotiate either anymore. And there's really only one real major downside to this, is if you use any sort of WAN devices which shape SMB traffic, and there's a variety of them out there, they have to be updated typically with newer firmware or software to understand this behavior. And when we see problems, it's people who are running out-of-date versions of these. All the vendors support it now. We meet with, the whole point to us with SNIA is that we do Plugfest. We meet with manufacturers of SMB and manufacturers of devices who use SMB for years before we release the protocol, and guarantee that we all know, everybody knows what the rules are going to be on this coming protocol. And in fact, we establish and lock down the protocols very early in the dev cycle of Windows to give everybody enough time to catch up. So if you run a really old WAN accelerator with a really old OS on it, it would see this whole conversation as being bizarre and bad, and it would break, because we're suddenly adding an entire phase of events that didn't have to happen in the past. Like right here in the past, and it's a little hard to read because of the watermark of the copy right here, but unsigned versus signed, or unencrypted versus encrypted. The old conversation would look like this, and if you're a WAN accelerator, you're expecting a conversation to be inspectable and touchable. And now, the conversation where you do a session setup is going to, you're taking your pre-authentication information, and it's coming back with signed setup response traffic. So there's no way for this reply to get tampered with by a man in the middle who says, like, no, this server doesn't support encryption. Trust me, there's no encryption here. That whole thing is now tamper protected. And then when we do that tree connect and the response, those are now protected as well. And that guarantees this entire phase here, that you don't end up with somebody not preventing you from connecting and not redirecting you to some other server, but from simply making the conversation with a nice server unsafe that they can watch the whole time. Which brings me to the last piece here, which throws a giant monkey wrench in all of this unless you do something about it. And that is called insecure guest auth. Insecure guest auth, or sometimes called insecure guest logon. And I made up the name insecure guest because I was trying to come up with this name that would make everybody say, wow, this sounds really bad, I should do something about it. And I'll tell you a little horrible story at the end of this. What it does is it stops guest usage on failed authentication. You may not realize this, but SMB, since the beginning of time in the Windows world, you will try to log on to something with your password, and you're trying to map a drive with your credentials. And you mistype the password. And then you would get an error, right? Bad username or password. And then you type it again, you're fine, you move on with your life, sort of irritated with yourself. What happens is if the server has the guest account enabled, or the guest sort of, authorization construct enabled, is by default, if your first attempt with a bad password works, the server will tell you and let you try again with guest. And it won't tell you that that's what happened. So you type a bad password, then it tries to use guest, and it works, and you get connected as guest, which is stupendously bad. Because if you think about it, if I was a bad person, and I could set up a server, and that server would let me connect any users to me without their knowledge that it wasn't really the server they were trying to go to, I'd be pretty happy as a bad person. And unfortunately, we have to leave this thing on by default because a huge portion of the world of storage that's made for consumers and small businesses actually uses the guest account still, and in many cases only uses the guest account. And if you make one of these things and you're on the call right now, you're a bad person and you should feel bad. They're doing it for a good reason. The good reason is I want my users to have a very simple experience that doesn't require my grandmother to have to understand password security practices. The bad reason is you have no security, and now your grandmother's pictures are all over the internet and her taxes and everything else. So we have a group policy that will turn this thing off. It's just called, enable insecure guest logons. By default, we do have this running, and so you're going to do the classic Microsoft disable the enable. The reason why this is got the goofy disable the enable, which makes everybody angry, is actually a real reason. When I first put this together and we first released it in the Windows preview phase around Tech Preview 2, it was disabled by default. We did block this. And then we ran into hundreds and hundreds of customers complaining that they couldn't connect to their home NASs anymore because they were using guest this whole time, either on purpose or they didn't know. And so we had to set it back to being off. By then, the registry value was out there, and it was too late to change it. If you configure this and you stop the problem, so we no longer will do guests anymore behind the covers from the client, it doesn't matter if you're still using SMB1. SMB1 we didn't change. It still does this bad behavior. We can't really touch SMB1 anymore. It is a deprecated protocol, which brings me to my secret point here that I'm going to get into before we get to the first round of questions. Even though this is an SMB3 session, I'm going to beat on SMB1 here while I have a good audience like you in front of me. SMB1 is Satan. And if you like using SMB1, you're really saying you like this guy right here. Anybody wants to know that's a black rain frog? It's a real thing that really exists, and it's from your nightmares, just like SMB1. SMB1 was deprecated many, many years ago. We've made it removable in Windows since 2012, R2. So for a couple of OSs now, you've been able to just toggle, get rid of SMB1, uninstall SMB1 from server and from client. You can also just turn it off at the driver level, and I get all kinds of interesting stories from customers about their deploying group policies and stuff these days. They don't want to go around removing SMB1 because they have to go touch clients. So they instead kill the SMB1 components, which is the simple matter of shooting 3 registry values. It is gone already from one of our server versions, the Nano server. If you're not familiar, Windows Server 2016 has an install mode called Nano. It's a very lightweight, mostly for container operations and for infrastructure, and it no longer includes SMB1. It's just simply not there. And then here's the second sneaky thing that I'm going to tell people here from SNIA who get to hear a little insider information. We are going to uninstall SMB1 in the next, not the creator update that you've been hearing so much about for Windows 10, but the one after that. For Windows 10 and Server 2016, it'll be gone from Enterprise Edition. It'll be gone from Server. It'll probably be gone from the IoT version and probably gone from the Education version. It will probably remain on by default in the Home version and the Pro version. And that's because I have, and I can't show it to you here because of this presentation software, and it'll be a little too hard to see anyway, even if I could. The telemetry I have, the hated Windows 10 telemetry, tells me a vast amount of information about SMB, which we've plumbed through. And we're down to just around 10% usage inside of the enterprise SKU. It's down to almost none on the server, almost none, almost unmeasurable. But on the enterprise SKU, it's down to about 10%. The Pro and the Home SKU, it's still at around 20%, which means we can't simply just flip a switch on that and blow up the whole world. But what we can do is make it so that enterprises will have to consciously go back to turn it on. And the people in that 10% range can use this opportunity over the next few months to go through and check with auditing to see why they're still using it. Why might they still be using it? Well, you might still have XP in 2003, or God help you, Windows 2000. I'm sure under a custom support agreement, positive that you are totally supported running these heinous, disgusting 14-year-old operating systems. It's very possible that your printers are mandating SMB1. They're a very common culprit. Things like scan to share and stuff like that often used SMB1 as a convenience point, not because it was any good. Even though the manufacturers of the software for those printers have provided SMB2 and 3 all the time. So it's really just a bad conscious decision, unfortunately, by the manufacturers here. Those evil NAS devices that I talked about, definitely using SMB1. And then some older Linux iterations. SMB came around in Samba and in the CIFS client in the kernel early on, but it was a little bit behind on getting to SMB2. But you've had SMB2 in Linux/Samba now for many years. It's just a question of if you're still running something even older than those, or some distro which never got the memo. If you, just the last hammering point here, if you want to actually identify and get rid of SMB1, we offer a few mechanisms. This one is built into Windows Server 2016. We simply have an auditing mechanism. It's a little difficult to see here on the screen, but you can track SMB1 usage by client. It just adds another event log. And that way you can just enable this on your servers and say, like, who's using SMB1, and then go find out why. Sometimes they don't need to. Sometimes it's an accident. Sometimes they're really old devices you weren't even aware of. And sometimes it might be necessary. And if it's necessary, you can come up with a plan where you can try and get rid of SMB1 in most places and then just leave it on, just try to minimize your vulnerability. If you want to learn all of this stuff and how to get rid of SMB1 throughout your enterprise, that's the one thing to remember, that KB. And there's a blog post I wrote which effectively says the same things but in a goofy Ned fashion. My last secret SNIA announcement that no one else knows on the earth, and you get to know first. We have backported the auditing mechanism that I was just talking about to older versions of Windows Server as well. And that's going to be shipped as a cumulative update in the next few months. So no one knows that but you. You can't tell anybody. It's a big secret. I don't know, you can just tell anybody you want. I don't care. Okay, so first break. John,
all right, Ned, thank you. This has been really exciting. So I guess we've learned that if you have SMB1, it might be Satan. But in any case, you've told us how you can get rid of it and making sure that people know. So SMB1 is a slow, it's unsafe, chatty, and especially, once again, it's unsafe, so people should get rid of it, and you've shown us how. So a couple of questions here. So one question, and I think you've just answered this, but essentially, when will Microsoft officially drop support for SMB1?
Yeah, we're not going to probably never fully drop support, but we will simply, it's been deprecated. Like you can't right now say like I have a bug in SMB1 or I have a functionality bug in SMB1 or I have I want to add this great feature I came up with SMB1. None of that's going to happen. It's not going to go anywhere. I mean, technically we still support like Xenix and PC LAN and WFGnet and stuff. I mean, if you look at the telemetry, I actually right now will still see about 0.05 connections on less than SMB1, which is insanity.
Oh, okay.
But it's out there.
Right, but it sounds like, so even if you don't officially drop support, you explained that you're going to be removing it from new releases of Windows going forward. Maybe not all releases, but okay.
Yeah.
The next question is, it says, I'm curious if SMB signing also works with Samba and the SMB client built into Mac OS 10 or OS X.
Absolutely. Yes, absolutely.
Okay, great. So the SMB signing works. That's good news. And then the other question is, what is the minimum SMB version requirement to get decent performance across the WAN? Assuming I'm not going to use SMB1 because it's evil, can SMB2 provide good WAN performance, or do I have to go to SMB3 or 3.1.1?
Yeah, the goodness starts in SMB2. That's where you get directory caching and leasing and all those pieces that were done as WAN optimizers for the client. So that would be technically starting in Vista, or Windows 7 probably is what you'd really be using, Windows 7. That's all there. And then also that's supported from the Linux CIFS client since 2012, I want to say. So if you're on a relatively modern Linux distro and you're modifying your CIFS conf or whatever, SMB2, SMB 2.02 technically would be the one, or SMB 2.1.
Okay. All right. And one more question just came in before we go on. It's other than the audit setup, is there a way to determine via the operating system which SMB version is in use?
It's the auditing. Really, the only way to answer the question is a network captures. So you can tell from looking at the machine what it's capable of doing. To see what it actually is doing, it would be a network capture of some type.
Got it. Or I guess they could just go to the client and turn it off, but then if it turns out they are using it, they might get a surprise.
Yeah. So that's the funny part, but the auditing we have an additional message that you don't have to enable auditing to get. It'll just happen automatically, which is the oops, you messed up message that I call it, which is you've turned off SMB1. The servers will log a once a day, whenever it happens, throttle event that says, oh, somebody tried to connect an SMB1 and it didn't work out because you got rid of SMB1, dummy. And then you can find out that you can race to see if you can find the event first, or people can scream at you first. That's your two choices.
Okay, got it. All right, let's go on. In the interest of time, let's keep moving.
Okay. Good, because this is that's the lion's share. That's the 2/3. So this is the remaining third here. We'll talk about scale and perf. Scale in SMB terms is a couple of things. It's the SMB Transparent Failover, and that means the ability to understand when applications are, this is really kind of a clustering feature. Without clustering, it doesn't make a whole lot of sense. It's the idea that if I connect an SMB persistent handle to a machine, the servers and the nodes inside of a cluster who understand SMB3 will use this concept called the resume key filter to keep track of connections and the handles they have open and the data that they are accessing, so that if there's some interruption on the server, they can be moved somewhere else, and you'll get an I/O delay while the move happens, but you won't get like a disconnect. It won't crash. If this was a VM running, so like the VM's running on a hypervisor, and its actual disks are on a scale-out file server, the storage can move around, and the client can be told, like, just hang on a second, I'm going to move this storage because there's a problem with the node, and then you can we'll reattach you to it like nothing happened. So you get no downtime. It just pauses all the I/O, and then it brings you back and hands it back over to you. So it really is great for handling these planned and unplanned failovers. It really is, like I said, it's a cluster feature. There's no point in having this type of transparent failover if there's nowhere to failover to. So this is sort of it's not a Windows feature per se. This really is a protocol feature, but it's mostly implementation inside of Windows as a practical matter. So when you look at this from like a real perspective, if I have like a Hyper-V server plowing away on this cluster that's a file server pointing to some share, and then something happens to the node that I was actually, that actually was hosting the storage for that VM. What actually happens is the Hyper-V client, so to speak, in this case, is told like, hey, hang on a second. there's something happened to the node. I'm going to move its storage over to another one of these nodes, and I'm going to have you reconnect and to that share and get back to your stuff. And your VM will pause temporarily, install all the IOs, and just be told, like, just hang in there for a second, as if you had had some kind of, transient storage problem, even though the entire cluster node was exploded and gone maybe forever, and then reattach and keep going. So the nice thing about that is, if a VM is pointed to a VHD, the storage of a Windows VM, in the past, if the network connection went down, the VM would just, blue screen. There's no storage. The entire OS and all of its hard drives have disappeared on the running VM. That's not good. Now you're simply going to have a behavior of over SMB, the client of SMB being told, just hang on, reconnect over here. We actually have a specific Windows implementation detail called the witness, which is an extra side channel that goes and tries to quickly find other servers without trying to do SMB timeouts and stuff to look for them the normal way. But that's a specific Windows detail to get you reconnected, and then you're right back in business. And this really is kind of as you can see, the first angle here is really more of a data center type of operation. And then you have scale-out file server. You saw the share was the same on all the nodes. Scale-out file server means shares that are spread across all the nodes, but they're accessible by any node, and the storage is redirected under the nodes. So we use SMB to run Windows clusters for the CSV and redirection of I/O. And then we also use it to provide this shared active capability. So no matter, you just go to some share for the cluster, and no matter which node the storage is actually connected to right now, you'll be pointed to it under the covers and no one knows. You get, no downtime anymore unless the entire cluster is gone. You also get right through with our continuous availability option in SMB3, which is just a parameter on shares that says, every I/O that comes through this share must use forced unit access into the storage and be written through before we will return the I/O back to the app. So even though you're often writing to storage, you're really writing to caches and buffers, and that's how operating systems work. This is designed to say, no, we are only going to write to spots that are truly protected from interruption of power, which I just said there. An example of this here is just SMB3 being used as a fabric, like I talked about in the beginning. So I've got compute nodes along the top there that are running Hyper-V or something like that. They're passing through SMB3 into a cluster to be used as a scale-out file server. So the entire fabric is no longer. This is not iSCSI, this is not Fiber Channel, this is not any of those pieces. This entire thing is Ethernet and SMB3 providing all of the I/O up and down the stack and left and right in the stack. So that's scale. The last piece here is performance. A lot of the work done in SMB3 was to get rid of a lot of the the difference between SMB1 and SMB3 is so different that honestly, the name is really what joins them. They kept using SMB as a branding exercise, honestly, but we probably should have called it something different starting in SMB3 because it was so radically different from SMB1. They really weren't the same concept anymore. The first is multi-channel. Multi-channel means you can finally gain the full throughput of your network. You can aggregate bandwidth. You can have networks go and come, 3 or 4 NICs or interfaces, and it will simply fail over. Think of it as basically load balancing for SMB. It happens automatically. You really have to opt out because we find multiple paths, and based on the ones that have the best and fastest interfaces, we will use those compared to others. So you need to have at least RSS, Ethernet NICs, or multiple network adapters, or teamed NICs, which I hope you don't because teaming is kind of gross, or RDMA NICs. So what does that mean? Like here, on a 10 gig NIC, hopefully you can make out this diagram, I can take that 10 gig NIC with RSS and I can actually open up multiple channels in it for the same I/O and spread it along and actually gain the full throughput of the NIC in theory. Or I can take multiple smaller NICs and I'm effectively bonding them using multi-channel to get bandwidth out of several of them for the same I/O. Or I can take teamed NICs and use those as well, multiple team NICs. But ideally, I can get RDMA NICs. RDMA, I'll get to in a second here with more detail, means I'm getting the fastest and lowest latency networking. And then I'm using as many of those NICs as I possibly can to get some truly astonishing bandwidth. So SMB Direct is what we call it. It's really SMB over RDMA. It's super high throughput, low latency networking. Importantly, it really minimizes CPU usage. You can get all this kind of performance out of regular Ethernet. The cost is the motherboards of your machines are doing a lot more thinking, and you might not have very much left over for the workload. SMB Direct is saying, let's take all this processing and put it into the NICs themselves, the RNICs. And you're going to get automatic failover, bandwidth aggregation, all those pieces. But you're going to have to use specialty hardware for the first time in many years, made by within 3 standards. Chelsea makes the iWarp standard. Rocky is made by Mellanox, but it's also licensed to many other manufacturers. You can find other manufacturers of Rocky. And InfiniBand, which is a Mellanox proprietary one. And there's some, I couldn't really find some really good modern tables on this, because the last time we really checked or cared was back in 2012, but you can sort of see the difference in performance of the amount of throughput we can do compared to the more, and this is going to make some people feel bad, but legacy HPA style. Okay, I'm going to push through this question break here, John, just to make sure I can get to the end, and then we'll save the rest for questions, okay?
Please go ahead.
Thanks. Okay, so the last thing is I want to give a couple real-world examples. This will only take a minute, and then I can take the last few minutes in questions. This is a real-world example because instead of a marketing guy, you get to see me in my element. All right. Storage Spaces Direct is an example of a highly SMB-utilized product that we just started to make in Server 2016. It's taking SMB 3.1.1 and using that as a fabric to form hyper-converged storage. Hyper-converged means that all the virtualization and networking and storage is all combined into a single cluster. And the fabric of that cluster is Ethernet, and SMB is the transport and mover of all those blocks. So it'll place blocks all around, it'll put them on tiers, it'll move them between the types of different storage, all using SMB. And an example of that would be here where we have these, we have this example we did with HPE of a 12 server cluster with Mellanox Rocky NICs, Rocky V2 NICs. And we just built a single storage pool with 48 NVMe drives. And we loaded up 336 VMs on top of that and gave it a 512K random read workload. So we just take disk speed and we shove it in using this tool called VM Fleet, which you can get off of our GitHub site for creating workloads inside of running VMs. And so this is all SMB3. This is all straight Ethernet, Rocky V2. And we're able to push through this 12-node cluster 160 gigabytes per second of 512 reads. That's a pretty astonishing number. That's 1.2 terabits per second of just raw read I/O coming out of these 336 VMs, all using SMB. No, nothing up my sleeve. And at the same time, because we're using SMB Direct, we're using RDMA enabled SMB, a lot of the processing here is going from the NICs and not from the server. So to do all this and to push all this stuff, running all these tools inside those VMs, who are doing the real work, we still only used up a quarter of the cluster's CPU, which is not so bad. At least you have plenty of, overhead for other things. And obviously, this is one of those crazy psycho tech demos where nobody would ever actually get anywhere near this because that's nonsense brochure stuff. We also support live migration over SMB, another real-world example. So when you migrate VMs around using RDMA with multi-channel, you can get some really good performance gains. Like here's the old-fashioned TCP way of live migrating a VM. It would take, like in this particular rig, a minute. If you did it compressed, it would take, about a quarter of that. And then if you did it with RDMA, it would take even less than that, but also have no hit. Like the compressed one eats your CPUs to oblivion. Ours is faster and costs you nothing, which is pretty sharp. And then you have things like Storage Replica, which is a block replication engine we added in 2016. It's something I own, where we use SMB as the as the block transport. So we're replicating every I/O, write I/O between two nodes and all their storage over SMB the entire time. Now we have a lot of vendors who are already in this game. Apple went into SMB pretty early. EMC and NetApp are two big SMB users. I'm not going to name everybody here because it would fill up this slide. And then we also have, this is all alphabetical, 3 major vendors of SMB itself, for UC, Tuxera, and Visuality, who manufacture and build their versions of SMB for you to run under license typically, or to run as a, if you make hardware and you want to be able to run SMB on it. But there's a lot here, and if you want to find out more about them, there's an entire consortium you can talk to John about. Okay. You're all going to get this slide, so take a quick picture, or you can have this slide, handed to you when we're all done. But these are everything I talked about. All of it is inside of these 5 URLs. If you can't find the answer or the detail or the real depth of what I was talking about here, just hit me up and I will get it for you. I promise. Let that sink in for a second. Okay. Now, that is the time I have set aside for this. I'm going to let John take over here real quick, and then we can get some questions, and then you guys can go have a fun morning. Thanks very much for your time. I really appreciate it.
Ned, thank you. And I think I'm going to try to push the webcast a few minutes past the hour, about 5 minutes extra, to get to the questions after we finish these slides. So I do want to put in a quick plug for the 2017 SNIA SMB Plugfest. There are typically 2 SMB Plugfests each year. SNIA hosts one every September, and this year it will be September 11th through 14th in Santa Clara, California. If you make a product that supports SMB, such as SMB3, and you are not involved, I encourage you to contact, to find out about this. You can search on it either on the Microsoft web pages or the SNIA web pages and get involved. Bring your software or your hardware, test it out with other SMB vendors. So that Plugfest is there. And it includes a reception and some other participation in the SNIA Storage Developers Conference. And I believe there's also another Plugfest held at Microsoft in Redmond in June of each year. For example, last year at the SNIA Storage Developers Conference at the SMB3 Plugfest, these are some of the vendors who were there. So you can see there's a good selection of both software and hardware vendors who support SMB3. And again, if you are a vendor and you make a product that supports it, or would like to, I encourage you to participate in this Plugfest. So now we have a bunch of questions that have rolled in, and let's go back to Ned with some of those questions. So let's see. One question is, does transparent failover apply to just Windows, or could it also work if you have a non-Windows product supporting SMB, like that supports SMB 3.1, like NetApp, for example, like a NetApp filer?
It absolutely can work with third parties, and you just have to look and ask that vendor in their implementation if they've added. That is one of the should and may portions of our quasi-RFC, the protocol, which we document on our MSDN site. That's one that is not required, so they may or may not support it. You'll have to ask them. Many of them do now at this stage, but you'll have to ask them for specific implementation details.
Okay, sounds good. Another question is there a way to change the block size in SMB3?
No, not really. Email me more offline if you want to talk more about that.
All right, so the person who asked that question, remember it's on Twitter at nerdpile or nedpile@microsoft.com. All right. What is the name of the I/O application you were using? Did you say that was disk speed? Yes,
that was disk speed. It is, let's just look for DISK-SPD on the internet. We have a downloadable version, and you can also go to GitHub, and actually it's open source, so if you wanted to psychotically, make some changes to it, you can as well. Okay, and there's someone who's saying that he's not sure he believes your I/O data tests, because how could you achieve 168 gigabits per second from 10 gig network cards? Did you have to trunk a bunch of network cards together to get that level of throughput? Yeah, they weren't. The 160 gigabytes a second, those are Rocky 100 gigabit network cards.
Okay, so you're using
not
multiple
10.
100 gigabit connections to get the 168 gigabytes per second.
Yeah, every node had two Rocky V2 100 gigabit ports. Yes. The I/O we actually ran out of storage I/O. We didn't run out of network I/O.
Okay, and let's see.
That's a great question.
Well, okay, one question is, okay, some of these features about, I presume they're talking about SMB 3.1.1 are great, but how many of these features will end up locking out FOSS or GPL implementations of SMB such as in Samba? So maybe that's indirectly asking, well, how much of these features are supported in Samba?
Zero. We work with Steve French. We work with Jeremy. We work with all the Samba guys directly. We speak to them constantly. We meet with them several times a year, and we ensure we have like we would say with the British, we have a special relationship with the Samba team to ensure that they 100% can do anything that we make themselves, and we don't lock anybody out of a feature-wise piece. We make sure that we document the entire protocol, both by our own goodwill and by decree, if you remember from maybe 10 years ago. And anybody can. It's a question of will and resources and time and money, but anyone can make SMB3 do anything that it can do in Windows, 100%.
Okay, very good. So actually, I wanted to add a couple of clarifications and questions that I thought of. So I want to make it clear. Tell me if this is correct. So if you want to do SMB multi-channel, or if you want to do storage spaces direct, or you want to do the live migration, I'm saying those do not require RDMA, correct? Those can all run using SMB3.1.1 over TCP/IP as well.
Yeah, absolutely. In fact, we even just put out a blog post a few days or weeks ago demonstrating an SMB Direct setup. A storage spaces direct. We have a little too much direct, a little too much storage, a little too much spaces. A storage spaces direct cluster using just Ethernet TCP/IP. There's no requirement. There's no mandate. It's a question of if your workloads are going to start consuming more of the CPU's time pushing blocks around to do placement in a two-way or three-way mirror or in a parity set across this pool of spaces volumes, or if RDMA is going to be there to take away a lot of that overhead and thinking. But if you were to say create a two-node cluster, like a two-node cluster that's running 15 VMs, there's no point to putting RDMA in there at all. That would just be ridiculous. You would just use regular 10 gig Ethernet probably.
Okay, so on a bigger or more intensely loaded cluster, RDMA can improve the performance, but it's optional.
It's absolutely optional at all times. It just comes down to, what kind of workloads are you running and what do you want to have your computers thinking about.
Okay. Another question is, SMB as a protocol, is it a stateful or stateless protocol?
It's pretty stateful. I mean, what else do you want to know?
Okay. All right. So I thought it was. I just wanted to be sure. And,
yes, it's stateful.
And back to the question about if you want to do this hyper-converged with Windows and you've got like storage spaces direct, do you have to use SMB 3.1.1 or could you just use SMB 3.1 or SMB 3.0?
I say that one more time. I missed the beginning.
Do you need SMB 3.1.1 to do the hyper-converged configuration with storage spaces?
Oh, that just happens naturally inside of Windows. The features that do storage spaces direct, for example, comes only in Server 2016, which means it's going to do 3.1.1, and there's no way to make it do less because that's the protocol that is the highest one, and negotiation is always going to lead to it using that. There are plenty of interesting problems that might occur if you were able to somehow cripple the protocol down to a lower level and then but let modern features run over it. That certainly wouldn't be supported. And we certainly don't test it, so I couldn't even think what might happen, but I'm sure we would find some insane, hilarious bugs if we tried.
Got it. Okay. So back to the live audience questions. So there's a comment, maybe not a question, that from Chris on the Samba team, that the Samba team will be meeting in May in Europe, and Microsoft will be part of that. So that's just a comment.
Hi, Chris.
And yes, so hello, shout out to Chris there. And there's a question, can you please post, or request, can you please post links to the tools you mentioned in the presentation and the I/O tests? Do you have a comparison using Iometer or Iometer Can those links or tools all be found from those links that you posted in the slide?
Yeah, they're all, you could dig them out, and we can make sure I get John and Diane to get you the links. Really what you're looking for is disk speed, VM fleet, and we have another one called PCS. And we use these, we've actually been providing these to the storage manufacturers and server manufacturers as a way, as part of our logo process now. But they are open source and public. The iometer question is disk speed. The difference between disk speed and iometer is they both generate I/O and they both display it. Disk speed displays it on a console, and iometer displays it in a nice dashboard. And I've been kicking around the idea of us making kind of a graphical version of disk speed so that we will stop looking like we're from 1993. But in the end, they do the same thing. They generate the same workloads. They will allow you to change the characteristics of the I/O the same way. So it comes down to being a matter of taste.
Okay, so it's a more matter of taste. Not that one tool is clearly better or preferred over the other. You can use either one.
I would say that iometer is clearly better in rendering the information. Disk speed is clearly better in the fact that you can use it and change it and modify it. It's very actively developed, and iometer has been less so over the years. That's really the only real difference.
Okay, I think we can take one more question. We've gone a couple minutes over the hour. So the question is, if I have old Linux with a NetApp filer running in 7 mode, which is, I guess, not their clustered mode, and I have Windows Server 2003, am I forced to use SMB1, or can I still get rid of SMB1 and use newer versions of SMB?
It's a good question that would be for the NetApp folks. I don't know.
That's a good point.
Yeah. It comes down to what the server is demanding. Yeah.
All right. What about Windows Server 2003? Well, maybe that part of the question. I assume that supports SMB2 but not SMB3?
Just SMB1.
Okay, so I guess if you are using Windows Server 2003, which I hope all of you are not out there, but then you might still be stuck with SMB1.
That's right.
Okay, and the answer would be upgrade to a newer version of Windows. And then on the NetApp side, as you said, ask NetApp. Okay. All right. Okay, and someone just put a comment saying the same thing. So I think that's all the time we have. I would like to say, let me see if there was a closing. I forgot there's a closing slide. I would like to thank everyone who attended, and a big thanks to Ned for being our presenter today. I would like to ask that you rate this webcast. You can click on the ratings button within your BrightTalk viewing screen. You can provide a rating as well as comments. Comments are always, and ratings are both welcome. You can download these slides right after this webcast is over. You will be able to download these slides as a PDF. You can also watch a replay of it or refer this to your friends or your enemies by sending them to the SNIA.org website. Go to snia.org/forum/ESF knowledge webcasts, or just search for SNIA ESF webcasts, and you could search in Bing or Google and find that pretty easily. We will post all these questions and answers, plus any questions that we didn't get to in a blog. We usually try to post it in about a week or week and a half, and that'll be posted on the SNIA website. And you can follow us on Twitter at SNIA ESF. Again, if you want to ask Ned questions directly or follow him on Twitter, he's at Nerdpyle, Nerdpyle. Other than that, again, a big thank you to everyone who attended, for those who asked questions or just enjoyed the commentary, as well as for Ned for presenting. I encourage you to check out our past and future webcasts. All of the past ones are available for replay, and all the next 3 or 4 upcoming ones are listed in BrightTalk, and you can sign up for them now. Again, Ned, thank you, and we'll be signing off from this webcast, and that's it for today.
Thanks, everybody.